This is a short video of the subtraction rule, and at least one because this is what I get the most questions on every year. So let's think about the background first. Our subtraction rule comes about because we know that all probabilities have to add up to 1. Okay, so for example, let's say we have some candy and we know the probabilities of each color, and I ask you, what's the chance of getting a red candy? Well, the probability of red equals just 1. Sorry. The probability of red is simple. I look at it, it tells me it's 0.25. Now, what's the chance of getting a not red candy? Well, there's 2 ways you could do this. So let's do the long way first, which is to list out everything that is not red. So everything that is not red would be this chunk right here. So the probability of not red would be probability of blue or yellow or green or purple. Depending on when you watch this, we may or may not have looked at the video where we learned about ORs, but for ORs, we just add up our probabilities. So if we want blue or yellow or green or purple, we could just add all those up. So 0.15 plus 0.05 plus 0.35 plus 0.20 gives me 0.75. So that's kind of a long way, and that was with only 4 other options. Let's try our shortcut. Let's try the subtraction rule, which says everything has to add up to 1. Okay, so if everything has to add up to 1, then we could say the probability of not red, that's the opposite of red. So we'll do 1 minus the probability of red. So 1 minus the probability of red, which we found up above is 0.25, tells me it's 0.75. Much faster and easier to do, especially if you have a more complicated problem. Next example. If the chance of picking a person with a college degree is 40%, what's the chance of picking someone that does not have a college degree? So I'd say the probability of not college equals 1 minus the probability of college. And then I just have to figure out what's the probability of college. They told me it's 40%. So if I want to do percent, instead of doing a 1, I would write 100%, because 100% is the same as 1. So we'll do 100% minus 40% equals 60%. And in Renly's car, there are 15 CDs. If there's 4 country, what's the chance of picking one that is not country? So probability of not country equals 1 minus the probability of country. So 1 minus the probability of country, well, there are 4 countries, 15 total, so 1 minus 4 out of 15 gives me 11 out of 15 chance of getting something that is not country. Now, those are all very simple problems. Let's look at the next page. So anytime we are asked to find the chance of at least 1, it is faster to do 1 minus the probability of none. Okay, not the only way you can do it, but much, much faster often, especially when you get to more complicated problems. So we're going to kind of prove how and why this works. Suppose in a certain town you have a 0.45 chance of meeting a person who's renting and everyone else owns their home. So what's the chance of meeting someone who owns their home? So the probability that they own is just going to be 1 minus the probability of renting, because you either rent or own. Those two are opposites. So 1 minus 0.45 equals 0.55. So if you meet 3 people, what are the possibilities for if they rent or own the home? And we want to find the chance for each possible outcome. Now, I'm not going to teach you guys in this class how to do these tree diagrams, but they are useful if you ever have to list out all of the outcomes. So you don't have to understand what I'm doing or reproduce it. It's just helping me make sure I don't lose any outcomes. So if I look at the first person, they can rent or they can own. And then when I look at a second person, they can rent or own, rent or own. And then when I look at the third person, whether the first 2 are rent and own, I still have the choices of rent or own, rent or own, rent or own, rent or own. So what I do once I have that tree diagram, which again, you don't have to be able to reproduce that yourself, is I say, okay, if I look at my people, one of my outcomes is I can get rent, rent, rent. So I do rent and rent and rent. That's one of the possible outcomes. Once you get past 2 or 3 people, it's much easier to keep track of everything if you do a tree diagram. Okay, or I could have done rent and own. That's another possible outcome. I could have got rent and own. And so I just go through and I list out all of the possible outcomes. So I could do rent, own, rent. Rent and own and rent. Or I could do rent, own, own. Rent and own and own. To save time, I've gone ahead and filled out part of this table for us. So these are 8 possible outcomes if we look at 3 people and everyone is either rent or own. Those are the only 2 options. Now let's find the chance for each. So if I want to find the chance of rent and rent and rent, well, that would be 0.45 times 0.45 times 0.45. Anytime we do an and, we want to multiply our probabilities. So 0.0911. If I want rent and own, so that would be 0.45 times 0.45 times own, which is 0.55. So that gives me 0.1114. And so I have to find the probabilities like this for every single one. So my next one would be rent is 0.45, and means times, own is has a probability of 0.55, and rent is 0.45. See, so that's also 0.1114. Okay, if I want rent and own, well, those chances are 0.45 for rent times 0.55 for own times 0.55 for own, which gives me 0.1361. So these are 8 possible outcomes, and I'd have to find the chance for each one individually, which kind of takes a long time. Let's see, part 3 as an intermediate step is what is the chance of getting no renters? Okay, so no renters is, let's see, this own and own and own, that's the only thing that has no renters. So 0.1664. Now for number 4, it says, what is the chance of getting at least 1 renter? So the long way is I would actually have to go through and look at all of these different outcomes. So the probability of at least 1 rent and I find every outcome up here that has at least 1 rent. So that would be these 7 all have at least 1 renter. So I'd have to say probability of at least 1 rent, and I would have to write out rent and rent and rent. Or, and then I would do, let's see, rent and rent and rent. I could do rent, rent, own. Sometimes if we have ands, we just abbreviate like rent, rent, own. Or rent, own, rent. Or rent, own, own. Or own, rent, rent. Or own, rent, own. Or own, rent. Or own, rent. I hope I wrote all 7. If I missed one, go ahead and just fill it in yourself. Okay. And anytime we say an or, which if we haven't covered that yet, we just add up those probabilities. So now I have to add up these 7 probabilities. So 0.0911 plus 0.1114 plus 0.1114 plus 0.1361 plus 0.114 plus 0.1361 plus 0.1361, which gives me 0.8336. So that takes a really long time to actually do it the long way. Okay, and I was writing really fast. I was abbreviating it a lot. It takes a long time if you want to find the probability of at least 1 once you get to these complicated situations of like 3 people. Now imagine if I'd had asked you for 5 people or 10 people. Now suddenly you go from 8 outcomes to hundreds or thousands of outcomes. No one ever wants to do that the long way, which is why we have a shortcut. Okay. The shortcut is to use the subtraction rule, which is the probability of at least 1 renter, or anything that you want to talk about. The probability of at least 1 is 1 minus the probability of none, or no renters. Oh, we found that up above. Probability of no renters is 0.1664. So 1 minus 0.1664, which gives me 0.8336. So much easier and faster. Again, subtraction rule or complement rule, depending on which class you're in, It's there to save you time. You don't have to do it every time. You could find all A outcomes and find the answer the long way, but it's there to save you time.